This video is about contradiction proof. Some facts you really need to know. All rational numbers can be written as P over Q, where PQ are integers. Q is not equal to 0. And there are no common factors between P and Q. All even numbers can be written as 2 times n, where n is integers. Even numbers can be negative number. All odd numbers can be written as 2n plus 1, where n is integers. Odd numbers can be negative. If A equals n times B, where n, A, B are integers, A is called a multiple of n, and n is a factor of A. If P squared equals n times Q, where n is prime numbers, and PQ are integers, then P squared is a multiple of n, and also P is a multiple of n because n is a prime number, and can be written as P equals n times m, where m is integers. Let's talk about prime number. Prime number are positive integers. Only 1 and itself as factors. 1 is not a prime number because 1 has only one factor. All prime numbers have 2 factors, 1 and itself. So typical prime numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. Let's go to guided practice 1. Proof by contradiction. Square root of 3 is irrational. You always start with assume. Assume square root of 3 is rational. Then we will use the definition of a rational number. Square root of 3 equals P over Q. PQ are integers, and Q is not equal to 0, and there is no common factor between P and Q. Square root of 3 equals P over Q. First of all, get rid of this denominator times Q both sides. So we get square root of 3Q equals P. Then square both sides because we want to get rid of square root symbol. 3Q squared equals P squared. Then based on P squared equals 3Q squared, we could say P squared is a multiple of 3. Since 3 is a prime number, so P is also a multiple of 3. Then we can write down P equals 3 times n. This n is integers. Let's do the substitution. 3Q squared equals 3n squared. 3q squared equals 9n squared divided by 3 both sides. Q squared equals 3n squared. So q squared is a multiple of 3, which means q is also a multiple of 3. Q is a multiple of 3, which means 3 is a factor of Q. P is also a multiple of 3, means 3 is a factor of P, which is a contradiction to the assumption no common factor between P and Q. So we can draw a conclusion. Square root of 3 is irrational.